Since I'm not here to explain to you how to fill in these notes and do the activity you're about to do, I'm making this video so that you can still hear it straight from me. So you've already written down the parts of an atom: protons, neutrons, electrons. You know the masses and the charges and the locations of all those types of particles. What you're going to learn about right here are things called ions. And they're still atoms, but they're atoms that have either gained electrons or lost electrons. What that means is that the number of protons in the nucleus is not equal to the number of electrons in the electron cloud. So since protons are positive and electrons are negative, they normally cancel each other out, and an atom would not have any charge at all. The atom itself would be neutral. But if the number of protons and electrons are not the same, then we get an atom that has a charge. And that's what an ion is. It's an atom that has gained or lost electrons, and so it now has some sort of a charge, an electric charge. The way we write an ion is that we're going to put the element symbol from the periodic table, then we're going to put a plus sign or a minus sign depending on if it's positive or negative, and then we're going to put the value, like is it +1, is it -1, that number as part of a superscript. So this is the first time we're actually using a superscript. So for example, maybe you've seen me write this Cl-1. And what that means is that's a chlorine atom that has gained an electron and now has a -1 charge. Since electrons are negative, so an extra electron would make the atom negative. So we have two types of ions. We have positive ions and negative ions. This word is pronounced cation, and to help you remember that, give you a little visual aid. Here you go, little kitty ears. So a cation has lost electrons, and now it has a positive charge. What that means is it now has more protons in the nucleus than electrons in the electron cloud. So one way you might be able to remember that is it's cat, there's a plus sign right here. Maybe we turn that into a little kitty nose, a few little kitty whiskers right here. I don't really know how to draw kitty eyes very well. Then we draw a couple kitty ears right here. And so now that plus sign tells us it's a cat ion. Some examples of common cations are the sodium ion, so Na+1. I like to put the plus sign before the number, but let's say it's calcium. Sometimes people like to put the number and then the plus sign. This one would be +2, sodium's +1. So now let's talk about anion, so I don't need ears anymore. An anion has gained electrons, and so it's going to have a negative charge. It has taken on more electrons, so now the number of electrons it has is greater than the number of protons in the nucleus, so that's going to make it have a negative charge. I haven't come up with a cutesy little picture for this one, but what some people in other classes told me is you could make that negative sign the middle of an A. It's not cutesy. If you come up with something cutesy, let me know. I'm not making this any better. So here's our negative sign, so remember that anions are negative. So some examples, I won't use chlorine again. I could use an oxide ion, it's O, and it's -2. Or maybe fluoride, that's what's in your toothpaste. And I'll do this one the backwards way, where we put the number and then we put the minus sign. So fill this in the middle of page 4, and we'll pause the video to give you time to do that. Now on the bottom of page 4, you're going to do an activity where you're going to use some models of atoms that look a lot like this. The nucleus is going to be made up of two different kinds of beads, red beads and white beads, and then the electrons are these black beads on the outside. So don't write this one in on your chart. I want you to actually use the ones you get to touch, but I'm going to show you how to fill in this chart using the models. So the first thing it wants is the dish code. So if you look on the side of the Petri dish, you're going to see some sort of a number with a letter. I'm just going to put EX here because it's the example. But you're going to have like maybe an 18A or something like that. So this tells us here that the red ones are the protons. And that's why I color-coded this stuff on the earlier slide. Because when you look in the nucleus and we see the reds, we're going to count that there are 4 of them. That means there are 4 protons in this model of an atom. The next thing it asks for is the number of electrons, which are the black ones out here. And there are 2 electrons. Now I have to look at the charge of this atom model. I have to decide if it's overall positive or negative and how much. So since I see more protons than electrons, that means it's positive. And the difference in those two is 2. So this atom here would have a positive 2 charge. Since it's positive, it's a cation, so we would write cation right here. So then the next thing it asks for is the number of neutrons. They're the white beads in the nucleus. So I would count 1, 2, 3, 4, 5, 6, and I'd write my 6 right there. Well, now it wants the mass number, and I recommend you write this in on your chart so that you remember mass number is the sum of the things in the nucleus. It's the protons plus the neutrons. So I'll take this 6 and I have to go way back over here and add it to this 4, and I get that my mass number is 10. Now I want to represent the name of this atom in the 2 different types of isotope notation. There's the easy one called hyphenated isotope notation that has a hyphen right in the middle, and then there's nuclear isotope notation, which is a little bit more complicated. So for the hyphenated one, I need to first figure out the name of this atom. And the name is going to come from the atomic number. The atomic number is equal to the number of protons. So I look up on the periodic table, look up above the board, atomic number 4, and that one's going to be beryllium. And you should remember how to spell beryllium. And then there's a hyphen. And after the hyphen, I'm going to put the mass number. So this 10 that I just wrote, I'm going to put that right here. So this is beryllium 10. The next form is called nuclear isotope notation. And instead of the name, it just wants the symbol for beryllium, which you should remember is capital B lowercase e. It's kind of small on the screen, but it says on your paper the top number needs to be the mass number. So I'm going to put a 10 as a superscript on the left. Then it wants the atomic number, so I'm going to put a 4 as a subscript on the left. What it doesn't say here is that if there was a charge, if there was any kind of a charge from this column over here, we would put it as a superscript on the right. Because this one has a +2 charge, I'm going to write +2 right here. But a lot of the ones you're going to do are going to be neutral. They're going to have no charge. So in that case, you just wouldn't put something in that location. You're supposed to do 8 different Petri dishes. I want you to do this in the sage and scribe structure where one partner has the dish in their hand and they're counting up the numbers and they're telling the other partner what to write. The scribe has maybe both packets and is writing this information in both packets for you. And just make sure that you switch roles after each dish that you do.